When you hear the word calculus, do you think of any of these things? Impossible, terrifying, unnecessary, extremely difficult only for geniuses, or it cannot really be applied to real life? Well, then you're kind of mistaken. First of all, calculus has many applications. Let's say you have a car that's moving at constant velocity, covering a distance of 9 meters in 3 seconds. Well, the car's velocity at any time is going to be 9 meters over 3 seconds or 3 meters per second. But let's say you have a car that's accelerating, moving faster and faster as time goes by. If I ask you a question, what's the car's velocity at 2 seconds? Well, this doesn't seem as easy as the one before. In this case, you need calculus. If you want to find the area of a pizza, you can use the equation area is pi r squared. If you want to find an area of a rectangular paper, you can use the equation area is width times height. But if you want to find the area of something more complex, like the cross section of this mountain when it's cut by a vertical plane, then you're gonna need calculus. So is any of this hard? No, as I'm about to show you, calculus is very easy to understand. Before we get started, there are two branches of calculus. There's differential and integral. Differential calculus deals with the rate of change of something or how fast something is changing with respect to something else. Integral calculus deals with area under a curve. In this video, due to time constraint, I'm going to focus on differential calculus. Before we actually get started with differential calculus, there are two concepts you need to know, and those are limit and slope. To understand limit, you need to know what it means to approach. Well, approach means getting closer and closer to something. In an example sentence, my math grade approached 0% as end of semester approached. That's unfortunate. Let's say you have a line that looks something like this, and I ask you this question. What does y seem to be approaching as x is getting closer and closer to 1? That is, what is y getting closer to as x is approaching this point? Well, as you can see, y value is approaching 2. And how we write this mathematically is like this. Limit as x is approaching 1 of y is 2. All this means is that x is getting closer and closer to 1, y is approaching 2. Second thing, slope is defined to be change in y over change in x, which is also written like this. For this line, as x is changing by 1, change in x is 1, y is changing by 2. So slope of this line is going to be 2 over 1 over 2. And as you can see, 2 means y is changing by 2 every time x is changing by 1. So it's telling you how fast y is changing. So slope is the rate of change or how fast something is changing with respect to something else. Now let's get started with differential calculus. Let's say you have a car that's accelerating, covering a distance of 1 meter in 1 second. It's at 4 meter at 2 seconds, and it's at 9 meters at 3 seconds. If we call the time above to be t and position below to be p and plot this, it's gonna look something like this. When time is 0, position is 0. When time is 1, it's 1. When time is 2, its position is 4. When time is 3, position is 9. And if you connect the dots, it's going to look like this. Well, what's the car's velocity at t equals 1? Well, because slope is the rate of change or how fast the position is changing, the velocity at time equals 1 is going to be the slope of the graph or the slope of the line that's going through the graph at time of 1. And we call this line the tangent line. So how do we find the slope of the tangent line? Well, let's think of it like this. Let's say you're adding h to 1 to get another point at 1 plus h. Well, if you connect the dots, you're going to get a secant line or line that goes through 2 points of the curve. What's going to be the slope of the secant line? Well, delta x is h because this is delta x. But what's changing y? Well, because this thing is positioned at 1 plus h and this is position at 1, change in y is going to be position at 1 plus h minus position of h, giving us the slope of change in y over change in x, or p of 1 plus h minus p of h over h. Now that's giving us the slope of the secant line, not the tangent line. So how can we make this approximation exact? Well, by reducing the value of h, this black point is going to move closer to the red point, and our secant line is going to change. If we even more reduce h, that is, h is approaching 0, our point is going to move even closer, and our secant line is going to even more resemble the tangent line. So we want h to approach 0. As h is approaching 0, our slope of secant line is going to become the slope of tangent line. So the slope of tangent line is going to be limit as h is approaching 0 of the slope of secant line. And this is written mathematically as p prime of 1. And this is derivative of p at time of 1. And this is how fast the car is moving at time of 1. And the derivative is what the entire differential calculus is about. So now you know basic calculus. Hooray!